Okay, welcome back to this Gramin school. Now we have already solved this all formula. We have already discussed this all formula. Now it's time to practice some questions related to this formula. That is on multiple singles. That is on 3a as well as on 2a. So, okay, so let's start. And in this session, first of all, we have this problem. In this problem, there is given that we have to find out the value of cos 2a where sin a equals 3y. Okay, so as cos 2a is given to find out, first of all, the things that is given is sin a, the value of sin a. And we know cos 2a can be written as in terms of sin a, that is cos 2a equals 1 minus 2 sin a square a. So we don't have to find out the value of cos square also because must as you know that cos 2a equals cos square a minus sin square a. Also, cos 2a equals 2 cos square a minus 1. And in both cases, we must have to find the value of cos a from the given sin a. But as sin a is given and we have to find out cos 2a, so we can easily apply this formula, that is cos 2a equals to 1 minus 2 sin square a, and we can find out the value of cos 2a. So cos 2a can be written as cos 2a equals 1 minus 2 sin square a, 2 sin square a. Okay, so 1 minus 2 sin square a, and so 1 minus, what will be the value of sin square a? Means 2 into 3 by 5 whole square. So it is going to be 1 minus 2 into 9 by 25. Okay, so the answer is 25 minus 18 upon 25, and the result will be how much? 25 minus 18, that is 7 by 25. So cos 2a equals 1 minus 2 sin square a, and we will put the value of sin a, and the value of sin a is 3 by 5. So the whole square of 3 by 5 is 9 by 25, and 2 into 9, that is 18. And on taking LCM and simplifying this expression, we will get 25 minus 18 by 25 equals 7 by 25. So this is cos 2a. Now for if sin 2a equals 24 by 25 and sin a equals 4 by 5, then find the value of cos a. We have to find the value of cos a. If sin a equals 4 by 5, so how you will find the value of sin cos a? It's very simple. From this sin a equals 4 by 5, you can also use the relation, that is cos square a equals 1 minus sin a square a, that is cos a equals root under 1 minus sin a square a. Or you can apply this formula, that is sin 2a equals 2 sin a into cos a, 2 sin a into cos a. Okay, and put the respective value. So sin 2a equals 24 by 25 equals 2 into sin a equals 4 by 5. So write 4 by 5 into cos a, and then on simplifying we will get cos a equals 24 by 25, 24 by 25, and add 4 to 8, so into 5 by into 8. Okay, so on simplifying we will get 8 3 is 24, 5 5 is 25. So the upper one is 3 by, and the denominator is 5. So cos a equals 3 by 5. You can also verify it by cos a equals root under 1 minus sin square a, 1 minus sin square a, and then put the value of sin square a. So you will get 1 minus 16 by 25. So it is going to be 25 minus 16 upon 25. So the result will be root under 9 by 25, and which is equal to 3 by 5. So in both way we can verify or we can obtain the value of cos a. So let's see the second question. Okay, again we have here the given result is sin a equals 4 by 5. Now we have to find the value of sin 2a, but we know the only formula for sin 2a equals 2 sin a into cos a, 2 sin a into cos a. But here you can see that only the value of sin a is given. So first of all we have to find out the value of cos a. Okay, so from given Here sin A equals 4 by 5. So cos A equals root under 1 minus sin A square A. And then from this we can obtain, that is 1 minus 16 by 25. That's going to be root under 25 minus 16, that is 9 by 25, and the result is 3 by 5. So here cos A equals 3 by 5, sin A is given, that is 4 by 5. So we can easily find out the value of sin 2A. So therefore sin 2A equals 2 sin A into cos A, 2 sin A into cos A. That's equals 2 into sin A is 4 by 5. So 4 by 5 into cos A, that is 3 by 5. And the result is 4 to the 8, 324 by 25. So here you can see that sin 2A equals 24 by 5, sin A equals 4 by 5, and we have obtained the value of cos A in the second, and this C number is just the same as B. Okay, so in C we have given the value of, in B we have given the value of sin 2 and sin A, and we have to find out cos A. But here in C we are given the value of sin A, but we have to find out the value of cos A. And after getting the value of cos A, just put the value of sin A and cos A and obtain the value of sin 2A. So in this way we can easily find out. So let's see the next one. Okay, so in D we are given cos theta equals 12 by 13. We have to find out the value of sin 2 theta and cos 2 theta. Okay, first of all you have to be very sure that here sin 2 theta, we have only one formula in term of cos and sin, that is sin 2 theta equals 2 sin theta into cos theta. So as here cos theta is given, so we have to find out the value of sin theta also, or express sin theta in terms of cos theta. You can do any of the way. Okay, so here cos theta is 12 by 13. So we will find out sin theta equals root under 1 minus cos square theta, and this is going to be root under 1 minus 12 square means 144 upon 169. So it is root under 169 minus 144 by 169, and it is going to be root under 25 upon 69, 169. That is, the result is how much? 5 by 13. Okay, so sin theta is 5 by 13. You don't have to find out cos theta and sin theta both in while finding out cos 2 theta, but in case of sin 2 theta, it's better to find out cos theta as well. If cos theta is given, then find sin theta. If sin theta is given, then find cos theta. Okay, so now we can write, we have to find out sin 2 theta and cos 2 theta, the value of sin 2 theta and cos 2 theta. So sin 2 theta equals 2 sin theta into cos theta, and it's going to be 2. What is sin theta here? Sin theta is 5 by 13, and cos theta is 12 by 13. So here it is 120 upon 160. So this is sin 2 theta. Okay, now cos 2 theta. So cos 2 theta equals, we can apply any of the formula. You can use cos 2 theta equals cos square theta minus sin square theta, or cos 2 theta equals 2 cos square theta minus 1, or you can also apply cos 2 theta equals 1 minus 2 sin square theta. So you can use any of the formula as you require. But as here cos theta is given, so it's better to use this formula, cos 2 theta equals 2 cos square theta minus 1. And we have also found out the value of sin theta, so you can also use this formula. Okay, according to your choice, you can use any of them. So using this formula, cos 2 theta equals 2 cos square theta minus 1, we can get the value of cos 2 theta, that is 2 cos square theta minus 1 equals 2 into cos square theta here, that is 12 by 13, and on squaring this, so it is going to be 144 by 169 minus 1. So how much the result is? It is here 169, 2 into 144 minus 169. Okay, so it is 428, 428, 222. So 288 minus 169 by 169. So the result is 7, 1, that is 288 upon 169, that is 18 minus 9 is 9, and this 7 minus 6 is 1, 119. So the result is 119. By 116. So we have obtained also cos 2 theta. Okay, so let's check another. Here tan theta equals 3 by 4. Here tan theta equals 3 by 4. We have to find out the value of sin 2 theta and tan 2 theta. And we know sin 2 theta in terms of tan theta. Here sin 2 theta in terms of tan theta is 2 tan A upon 1 plus tan square theta. So you can use this formula and get the value of sin 2 theta. And we have also to find out tan 2 theta. So here tan theta equals 3 by 4, and here tan 2 theta equals here where it is this one, tan 2 theta equals 2 tan A upon 1 minus tan square A, or we can say tan 2 theta equals 2 tan theta divided by 1 minus tan square theta. So using this formula you can find out the value of this sin 2 theta and tan 2 theta. Okay, so let's see another one. Here it is sin alpha equals 1 by 2. We have to find out the value of sin 3 alpha and cos 3 alpha. Okay, as sin alpha is given, we can easily apply the value of sin 3a, and we know sin 3a equals 3 sin a minus 4 sin qa, 3 sin a minus 4 sin qa, and using this formula we can easily obtain the value of sin 3a. Again here cos 3a equals, we know cos 3 equals 4 cos qa minus 3 cos a, but here sin alpha is given, so we will apply cos alpha equals root under 1 minus sin square alpha a, and we will obtain the value of cos alpha, and using this value for cos 3 alpha we can obtain the value of cos 3 alpha using this relation, that is cos 3 alpha equals 4 cos q alpha minus 3 cos alpha. And here in G you can see that if cos alpha equals root under 3 by 2, then we have to find out the value of sin 3 alpha and cos 3 alpha. Again here cos alpha is given, that is 3 by 2. So here sin 3 alpha equals 3 sin a minus 4 sin cube a. So first convert this cos alpha into sin alpha, or obtain the value of sin alpha from this cos alpha. Okay, and then put this value in this sin 3 alpha, the formula for sin 3 alpha, that is 3 sin alpha minus 4 sin q alpha. And similarly for cos 3 alpha, here we have 4 cos q alpha minus 3 cos alpha. As cos alpha is given, so it is going to be very easy, so you can do it with yourself. Now in H you can see here that tan beta equals 1 by 2, and we have to find out the value of tan 3 beta. Here tan 3 beta means okay, so tan beta equals 1 by 2, and we have to find out the value of tan 3 beta. Now here you can see that tan 3 a equals 3 tan a minus tan cube a upon 1 minus 3 tan a square. So using this formula you can easily find out the value of tan 3 beta. And here if cos 2a equals 7 by 25, we have to find out sin A equals 3 by 4. Here cos 2A equals 7 by 25. And we have to find out the value of sin A equals, we have to prove that sin A equals 3 by 4. So using this cos 2A, we have to find out that sin A equals 3 by 4. So we know cos 2A equals how much? 1 minus 2 sin square A. And using this relation, you can easily find out 1 minus 2 sin square A. And here cos 2A equals 7 by 25. So to put the value of cos 2A. So 1 minus 2 sin square. So here 2 sin square A equals 1 minus 7 by 25. 7 by 25. Okay, so it is going to be 25 minus 7 upon 25 minus 7 upon 25. So 25 minus 7 is 18 by 25. And this is how much? 2 sin square. So sin square A is 18 by how much? 18 by 50. So sin A equals how much it is? Sin theta equals cos 2A equals 7 by 25. Then we have to find out sin A equals 3 by 2. So here cos 2A equals 1 minus 2 sin square A. So put the value of cos 2A, that is 7 by 25. That is 1 minus 2 sin square A. Okay. So we can write 1 minus 7 by 25. It is going to be 1 minus 25 minus 7. That is 25 minus 7 is 18. 18 by 25. And here it is in multiplication. So it is going to be in division form. That is 18 by 50. So sin A equals root under 18 by 50. And the result will be how much? 18 means 6 into 3 or 3 by 4. 4 5 is 23 by 4. And inside the what will be 2 by 5. 2 by 5. So here in this result we have left, that is sin A equals 3 by 4. 3 by 4 18 and by 3 by 2. 3 by oh no 5 4 is 20. Here you can see that we have given cos 2 equals sin by 25 and sin A equals 3 by 4. So what we will do here, cos 2A equals, we have the formula cos 2A equals 1 minus 2 sin square A. So we can write 1 minus 2 sin square A. Okay, so here what we can write, sin 2 sin square A equals 1 minus cos 2A. Okay, so here sin square A equals 1 minus cos 2A upon 2. And from this sin A equals plus minus root under 1 minus cos 2A upon 2. So it is going to be plus minus root under 1 minus cos square A means 1 minus 49 by 25 into 25. So it is it is cos 2A. So we write only 7 by 25. So 7 by 25. So 7 by 25 and the whole divided by 2. So the result will be 25 minus 7 upon 25 by 2. So the result is root under 25 minus 18 by 50. And here 18 by 50 means 6, 2 into 3 into 3 upon 2 into 5 into 5. So 2 is cancelled out, and here it is 3 by 5. 3 by. So this result is not 3 by 4, it is 3 by 5. Okay, so we found out the value of sine A. So we have proved sine A equals 3 by 5. Now in J, here it is given cos 2 equals minus 1 by 2, and we have to show that cos A equals 1 by 2. So how you will find out? Similarly, in the case as we have done in the case of sine A, we can also apply the same formula, that is cos 2A equals 2 cos square A minus 1, and putting the value of cos 2A, and on simplifying we will get the value of cos A, and we are going to prove that cos A equals 1 by 2. Now here you can see that we have solved a very simple and basic problems on these multiple angles, and now we will solve some proof. We have to prove some identities. So in first, here it is given sine A equals plus minus root under 1 minus cos 2A. And how this formula is obtained? Here you can see that cos 2A equals cos square A minus sine square A, and in next cos 2A equals 2 cos square A minus 1, and cos 2A equals 1 minus 2 sine square A. So using this relation, you can easily find out that sine A equals plus minus root under 1 minus cos 2A. So first of all, let's write cos 2A equals in terms of sine. So cos 2A equals 1 minus 2 sine square A, 1 minus 2 sine square A. Okay. So here, changing the side, that is 2 sine square A equals cos 2A minus, 1 minus cos 2A. Okay. So here, you can write sine square A equals root under, sine square A equals sine square A equals sine square A equals 1 minus cos 2A upon 2. Therefore sine A equals root under 1 minus cos 2A upon 2. So we have obtained that sine A equals, and as there is root, so we will write here plus no, because its value may be positive or negative. You know that. That is 4 equals square root of 4 equals plus minus 2. In the similar way, sine square A equals 1 minus cos 2A, and sine A equals how much? Plus minus root under 1 by 2. Okay. So we have obtained sine A equals plus minus root under 1 minus cos 2A by 2, and we have proved our LHS. We have proved RHS. Okay. So the next one is here cos A equals plus minus root under 1 minus cos 2A. So how to find out? So here you can see again here in the similar pattern that we have done in sine A while using this formula, and now we will apply which one? This formula, that is cos 2 equals 2 cos square A minus 1, and using this formula we can easily find out that B equals number B, that is cos A equals plus minus root under 1 plus cos 2A by 2. So let's see another. Here tan A equals plus minus root under 1 minus cos 2A upon 1 plus cos 2A. So here tan A equals plus minus root under 1 minus cos 2A upon 1 plus cos 2A. So here you know that is sine A equals we know sine A equals, we have obtained in this number A, that is sine A equals plus minus 1 minus cos 2A, and cos A equals 1 plus cos 2A upon 2. So we can easily obtain tan A, that is tan A equals sine A upon cos A. So on putting the value of these two, we can obtain that plus minus root under 1 minus cos 2A by 1 plus cos 2A, and where this 2 and 2 is cancelled out. So we can easily prove this tan A equals plus minus root under 1 minus cos 2A upon 1 plus cos 2A. So let's see another one. Here in D sec 2A equals cot square A plus 1 upon cot square A minus 1. So here cos 2A, sec 2A is 1 by cos 2, 1 by cos 2. Okay, so 1 by cos 2, and we know cos 2A in terms of cot. So we have also expressed this cos 2A in terms of cot. So here cos 2A equals cot square A minus 1 divided by cot square A plus 1. So just put the value of this cos 2A equals cot square A minus 1 upon cot square A plus 1. You will get sec 2A equals, where LHS equals sec 2A, that is LHS equal to 1 by cos 2A, and we know cos 2A equals 1 upon cot square A minus 1 into cot square A plus. So we have proved this using which relation? Using this relation, that is cos 2A equals cot square A minus 1 upon cot A. So we have proved this RHS. So RHS is okay. So we will solve different the next type of identity. So in the very first we have A equals sin 2A upon 1 plus cos 2A equals tan A. So how to prove this? We know sin 2A equals 2 sin A into cos A, and 1 plus we can prove in your own way, so in different way. But as the result is here tan A, so the numerator must be sin A and the denominator must be cos A. After simplifying, you can apply any way. But here sin 2A upon 1 plus sin 2A upon 1 plus cos 2A equals tan 2A. So here LHS equals sin 2A upon 1 plus cos 2A, 1 plus cos 2A, and here sin 2A equals 2 sin A into cos A, 2 sin A into cos A. You can write here 2 sin A into cos A. Okay, and here 1 plus cos 2A means 1 plus cos 2A means cos square A minus sin square. Okay, so what we can do? Just simplify 2 sin A into cos A, 2 sin A into cos A, and which is divided by 1 minus sin square is again here cos square A. So cos square A plus cos square A. Here this 1 minus sin square, 1 minus sin square, that is equal to cos square A, and this cos square. So it is going to be 2 sin A into cos A upon 2 cos square A. So here 2 is cancelled out and cos is cancelled out. So the what will be remaining? That is sin A upon cos A. So it is going to be tan A. And this is equal to RHS, where RHS is here in the next 1 minus cos 2A upon sin 2A equals tan, and 1 minus cos 2A. So you can just apply the same thing, that is 1 minus cos 2A, just put here 1 minus cos 2A equals 1 minus cos square A minus sin square A, so it is going to be sin square A. Now, and then 2 sin A means 2 sin A into cos A, 2 sin A into cos A, and this 1 minus sin square we will form sin square A. So sin square A plus sin square A is going to be 2 sin square A. Now, and the denominator is 2 sin A into cos A, and this sin A and sin A is cancelled out, and 2 is cancelled out. So the result will be sin A upon cos A, that is equal to tan. So it is tan. Again we have proved. So let's see another. You see sin 2a equals sin 2a upon 1 minus cos 2a equals cos 2a. We have to apply the same thing that we have done for a and b. Okay, and you can see 1 minus cos 2 theta upon 1 plus cos 2 theta equals tan square theta. So as here it is sin tan square theta, so the numerator will be sin square theta and the denominator will be cos square theta. So this is our target, and we know 1 minus cos 2 theta is 1 minus cos 2 theta. So from this relation we can apply. So what we have, cos 2a, from this cos 2a what we will get, cos 2 theta equals 2 cos square theta, 2 cos square theta minus 1, this in terms of cos. So 1 minus cos 2 theta is, so this is going to be 1 plus cos 2 theta. 1 plus cos 2 theta is equal to 2 cos square theta. No, so 1 minus cos 2 theta is going to be 2 sin square theta. So we 2 sin square theta. So we can easily write, we can easily replace this 1 minus cos 2 theta, 1 minus cos 2 theta by 2 sin square theta, and 1 plus cos 2 theta by 2 cos square theta. So here, and then we will obtain 2 is cancelled out. So we will obtain sin square theta upon cos square. So let's do. Here LHS is equal to 1 minus cos 2 theta upon 1 plus cos 2 theta, 1 plus cos 2 theta, and here 1 minus cos 2 theta means 1 minus cos 2 theta means 2 sin square theta. So we can write 2 sin square theta, and 1 plus cos 2 theta means 2 cos square theta. So 2 and 2 is cancelled out. So it is going to be sin square theta upon cos square theta, that is tan square. Hope you are understanding this. And as it is very simple and easy, so I am just I am not being very slow. I'm just doing it very fast so that we can complete all other problems. Okay, so we have completed, and this is going to be RHS, and so we have proved this one, that is 1 minus cos 2 theta upon 1 plus cos 2 theta is equal to tan square theta. So indeed 1 minus tan alpha upon 1 plus tan alpha, that is 1 minus sin 2 alpha upon cos 2 alpha. So 1 minus tan alpha, 1 minus tan alpha. So just here LHS for E, LHS is equal to 1 minus tan alpha, 1 minus tan alpha upon 1 plus tan alpha, tan alpha. So just we know tan alpha is sin alpha by cos alpha, so we can write 1 minus sin alpha upon cos alpha by 1 plus sin alpha upon cos alpha, sin alpha upon cos alpha. Okay, so here it is going to be cos alpha minus sin alpha upon cos alpha plus sin alpha, and cos is cancelled out. So cos alpha minus sin alpha by cos alpha plus sin alpha. Okay, so what we will do, we will rationalize, that is cos alpha minus sin alpha into cos alpha plus sin alpha by cos alpha plus sin alpha, cos alpha here it is 1 minus sin alpha, 1 minus cos alpha minus sin alpha. So it is cos alpha minus sin alpha, and it is cos alpha plus sin alpha. So no, this one is going to be negative. So cos alpha minus sin alpha, and here it is cos alpha plus sin alpha, and it is cos alpha minus sin alpha. What do you mean by this? That we multiply both numerator and denominator by cos alpha minus sin alpha. As the denominator is positive, cos alpha plus sin alpha, that's why we are multiplying both numerator and denominator by cos alpha minus sin alpha. So the result will be cos square alpha minus cos alpha minus sin alpha whole square. It is going to be a plus b whole square, that is cos alpha minus sin alpha the whole square. Okay, the whole square of cos alpha minus sin alpha, and the result and the denominator will be cos square alpha minus sin square alpha. And we know cos square alpha minus sin square alpha is cos square alpha minus sin square cos 2 alpha. So we have got the denominator, and let us simplify the numerator. So it is cos square alpha minus 2 sin alpha into cos alpha, that is a plus a minus b whole square, that is a square minus 2ab plus b square. So it is sin alpha into cos alpha plus sin square alpha, and this one is divided by cos square minus sin square alpha, cos square alpha minus sin square alpha. This is going to be cos twice alpha or cos 2 alpha, and here cos square alpha, and this one is plus sin square alpha, that is going to be 1. So 1 minus, and this 2 sin alpha into cos alpha is sin 2 alpha. So it is 1 minus 2 sin alpha upon cos 2 alpha. Cos 2 alpha. So we have proved this one. Okay. So it is proved. RHS is proved. So in F, we have to find out cos 2 theta upon 1 plus sin 2 theta is equal to 1 minus tan theta upon 1 plus tan theta. So here cos 2 theta is, again we can express this cos 2 theta in terms of tan theta, and we know cos theta in terms of tan theta, that is 1 minus tan square theta divided by 1 plus tan square theta. So you can use this formula also, and here 1 plus sin 2 theta. So again here sin 2 theta can be expressed in terms of tan theta. So you can use this formula. You can use this formula, and this formula, and using this formula and simplifying, you will get 1 minus tan theta upon 1 plus tan theta. So you can use any of them. Okay, so as your wish, or you can also use cos square theta minus sin square theta, and then on simplifying you will get the obtained, that is 1 minus tan theta upon 1 plus tan theta. Here you can relate this E and F number, and from 1 minus tan alpha by 1 plus tan alpha we have obtained 1 minus sin 2 alpha upon cos 2 alpha. But here it is reversed. Using this cos 2 alpha, cos 2 theta upon 1 plus sin 2 alpha, sin 2 theta, we have to obtain this 1 minus tan theta upon 1 plus tan theta. So use any of the formula. You can express this cos 2 theta in terms of cos square minus sin square, and this one in terms of 2 sin 2 theta, 1 plus sin 2 theta in terms of what? Sin 2 theta 2 sin theta into cos theta, and then simplify and express this sin by cos, and you will get 1 minus tan theta upon 1 plus tan theta. Or you can directly use this formula, and using this formula sin 2 theta equals 2 tan theta upon 1 plus tan square theta. As here it is theta, so I am reading it as theta, and cos 2 theta equals 1 minus tan square theta upon 1 plus tan square theta. So using this, any of the relation, you can easily solve this numerical error. Okay, so there is also some remaining here. In G, sin theta plus sin 2 theta, sin theta plus sin 2 theta is upon 1 plus cos theta plus cos 2 theta equal tan theta. I think I have to do this one. So here LHS is equal to sin theta plus sin 2 theta, sin 2 theta upon 1 plus cos theta plus cos 2 theta plus cos 2 theta. So how you will obtain tan theta? As here the RHS is tan theta, so the numerator must be sin theta, and the denominator must be cos theta. So here sin theta plus this sin 2 theta can be written as 2 sin theta into cos theta, 2 sin theta into cos theta. Okay, and denominator can be expressed as 1 plus cos theta, and this cos 2 theta can be expressed in terms of what? Cos. As it is, as we require denominator in terms of cos. So we have also the formula, that is cos 2 theta equals 2 cos square a minus 1. So we can easily express this one. So let's write 1 plus cos theta plus what? 2 cos square theta minus 1. So cos 2 theta can be written as 2 cos square theta minus 1. Okay, so this 1 and 1 is cancelled out, and we can take common in numerator, that is sin theta is the common here. So sin theta into 1 plus 2 cos theta, 1 plus 2 cos theta, and here it is 1 and 1 is cancelled out, so the remaining is cos theta. So we can take 1 plus 2 cos theta, and then the result is obvious. You can see here that sin theta by cos theta, and this 1 plus cos 2 theta and 1 plus cos 2 cos theta is cancelled out. So the result is sin theta by cos theta, that is tan theta. So we can easily prove this RHS. So here RHS is proved. So for 1 plus cos beta plus cos theta, nothing is done. Just we have taken the reciprocal of this g, and we can easily obtain this h number. So the same technique is applied here. Just do what we have done in g. So h can be also solved using this concept for g. In I, 1 minus sine 2 alpha upon cos 2 alpha equals 1 minus tan alpha upon 1 plus tan alpha. We have already proved this. So that is 1 minus tan alpha upon 1 plus tan alpha in the previous one. No. So, but here the one thing is added, that is tan 45 minus alpha. Tan 45 minus alpha. So let's do. First of all, we will prove this one, and then we will prove this one. So this one is LHS, this one is MHS, middle hand side, and this one is RHS. Okay, so first of all, we will prove LHS, then MHS, and from this middle hand side, we will obtain right hand side. Okay, so here LHS is equal to 1 minus sine 2 alpha upon cos 2 alpha. And you must have to understand that our target is to find out 1 minus tan alpha upon 1 plus tan alpha. So here 1 minus sine 2 alpha is how much? 1 minus sine 2 alpha can be written in terms of sine 2 alpha. Sine 2 tan A upon 1 plus tan A square. You can easily use this relation. And cos 2A in terms of tan A. That is cos 2A equals 1 minus tan A square upon 1 plus tan A square. So using this relation, that is sine 2 alpha is equal to 1 minus sine 2 alpha. So sine 2 alpha equals in terms of sine 2 tan A upon 1 plus tan A square. So 2 tan A upon 1 plus tan A square. 2 tan A upon 1 plus tan A square whole divided by cos 2 alpha, and cos 2 alpha is 1 minus tan A square A upon 1 plus tan A square. So 1 minus tan A square A upon 1 plus tan A square. 1 plus tan A square. Okay, we can write 1 plus tan A square A minus 2 tan A upon 1 minus tan A square. And this 1 plus tan A square and 1 plus tan A square is cancelled out. So 1 plus tan A square A into tan A, and just write the formula, that is tan A minus 1. What will be tan A minus 1 whole square? That is tan A square A minus 2 tan A and plus 1. So you can relate this expression 1 plus tan A square A minus 2 tan A by this tan A minus 1. So it is going to be tan A minus 1. Or we can write 1 minus tan. Tan A minus 1 or 1 minus tan. 1 minus tan A, any of them. So as you use, you can write. So as it is here given, that is 1 minus tan A square A, and this is going to be 1 plus tan A into 1 minus tan A. So let's write 1 minus tan. So it's better to write this tan A instead of tan A minus 1. It can be also written as 1 minus 2 tan A plus tan A square. So we can also write it as 1 minus tan A whole square. So we can write 1 minus tan A whole square, or whole square of 1 minus tan A upon 1 minus tan A square is 1 minus tan A square. So we can write it as 1 minus tan A into tan A, that is 1 minus tan A, by this 1 minus tan A square A can be written 1 minus tan A into 1 plus tan. So 1 minus tan A and 1 minus tan A is cancelled out, and the result is 1 minus tan A upon 1 plus tan. So we have also proved, as it is alpha, so replace this A by alpha. I have forgotten to write here alpha. So you can understand. So this is 1 minus tan A upon 1 plus tan A. That is 1 minus tan alpha upon 1 tan. Okay. So what is tan 40? Here it is written tan 45 minus A. You know that. So it is MHS. So middle hand side is proved. Now from this middle hand side, that is 1 minus tan A upon 1 plus tan A, we have to prove that it is tan 45 minus A. We know tan 45 degree is equal to, the value of tan 45 is 1. And we know tan A plus B is equal to tan A plus B equals tan A minus tan B upon 1 plus tan A into tan B. So we can easily write, here it is minus, so tan A minus tan B. So we can write tan A minus tan B upon 1 plus tan A into tan 1. So here tan 45 is, A is considered as 45. So tan 45. So we can write this one as tan 45 degree minus tan, how much? Alpha. This A is alpha. And 1 plus 1. Tan A into 1 means 1. Tan 45. So we can write tan 45 degree into tan alpha. And this result can be written as tan 45 degree minus alpha. So we can easily prove, and this is going to be RHS. So we have proved this RHS also. So it's very simple and very basic identities, and we have also solved this very in a very simple way. So the last, okay, so we have two last. So in J, what we do, tan theta plus cot 2 theta, cot theta. Tan theta plus cot theta equals cot 2 cosec theta. We know tan theta is 1 by sin 1 by cot theta, and cot theta is again 1 by tan theta. So you can do in any way. So we can write it as LHS equals 1 by cot theta, 1 by cot theta plus cot theta. So the result is here, cot theta equals, this one is how much? This one is 1 plus cot square theta, 1 plus cot square theta. And you have to remember one thing, that is cosec square theta minus cot square theta is equal to 1. So cosec square theta equals 1 plus cot square theta. So instead of this 1 plus cot square theta, we can write cosec square theta. Cosec square theta. So we can write here cosec square theta. But again we have this cot theta. So how to do this one? It's going to be very confusing. So it's better to express this tan theta and sin theta, cos theta in terms of sin and cos. So let's express this one in terms of sin and cos, and we can easily solve this one. So tan theta equals LHS. Here LHS is sin theta upon cos theta, and cot theta is cos theta upon sin theta. It's going to be very easy. So it is cos theta into sin theta, and this one is sin square theta plus cos square theta. Yes, it's very simple. Sin square theta plus cos square theta is 1, and this is going to be sin theta into cos theta. And we know cos theta. We know cosec 2 theta means, cosec 2 theta means cosec 2 theta can be 1 by sin 2 theta, 1 by sin 2 theta. So here it is sin theta and cos theta. We know sin 2 theta is 2 sin theta into cos theta. So the thing that is remaining is here 2. So if we add 2, we have also to multiply with 2. So we can easily write it as 2 upon sin 2 theta, and this is going to be 2 cosec 2 theta. So we have also proved this one as RHS is also proved here. So instead of converting it into or simplifying in terms of tan and cos, it's better to convert this or express this tan theta, simplify this tan theta in terms of sin theta and cos theta in terms of cos theta and sin theta, and then simplify. After simplifying, you can easily get the idea how to deal with it. Okay, so we have also proved this. And here k, in k, cosec 2a minus cot a equals cot 2a equals 10. Cosec 2a minus cot 2a equals 10. So how you will prove? Again you can express this one in terms of sine and cosec. So cosec 2a LHS is here, LHS is 1 by sine 2a, 1 by sine 2a minus this one is cos 2a upon sine 2a. Okay, so you can take here this one as sine 2a common, so it is 1 minus cos 2a, 1 minus cos 2a, and 1 minus cos 2a, again here 1 minus cos 2a, 1 minus cos 2a, 1 minus cos 2a is how much? 2 sine square a. So it can be written as 2 sine square a, and sine 2a is 2 sine a into cos a. So sine a and sine a is cancelled out, 2 and 2 is cancelled out, and the result will be sine a upon cos a. So it is going to be 10. So friend, for today we will do only this much, and in the next day or tomorrow we will complete the remaining up to what we can complete. So thanks for watching this video up to now, and it's my advice, just make a list of this formula. You have seen that this formula is very helpful, and if you have a list of this formula and keep this formula aside by while along with your notebook while practicing, which will make your work easier, and in this way we can easily find out you can easily find out the or prove the identities. Okay, and you can also remember the formula by practicing it time and again. So it's better to make the list of these all formula. Okay, so thanks for watching this video till the end, and hope see you next day. And